Okay, well, since you're gonna do that, well, yeah, since you're this now, I think you need to go and spend like $100 on a new camera.
$100 is funny.
Yeah. Gotta have a good webcam. Never know.
And after this year, this computer is going to be completely scrapped.
Oh, really?
Like, I mean,
How long have you had this?
literally just
How long have you had that computer?
5 years now.
Oh, that's not that old.
Yeah. I'm just gonna get better.
Oh, that's fair.
Like mine's on warranty. I'm really just gonna have it decent.
Really?
Just have it ready. Also, like I had heavy problems with my battery.
Yeah, exactly. My battery life.
My battery like lasts.
Well, that's just how that works when you have a PC, a laptop with an actual GPU in it.
Yes, right. It eats that shit.
Wait, who should I contact?
Well, Wade Borton. We could low key get to see what she said. Like TV screen.
I feel like Whittington would be too bad.
Whittington looking at it.
She'd probably like do it. Is what that's
I
like the
don't
thing.
want PTSD. Done with it.
I'm just saying Whittington would
But to
probably
be
say
fair,
yes.
Isn't it like, I mean, in the chemical engineering seminar, did Whittington talk about it?
I mean, I didn't have her in mind. Did she come to yours? Yeah, she didn't do mine.
You should do everything. No, I was going to do everything wrong.
Your
No,
professor?
Archini? I think you should do Archini.
She. Let's not.
Archini.
Let's not.
Let's see, who else can we do? I love how I said we. What's that mean? Hey, I'm very
I'm
experienced.
combining
Yes,
accent,
it has.
accent works because I don't care.
And we're gonna have AICHE on it too a little bit.
Let me think.
Matthew has like the social experience.
I also just like the problem.
I say you should go Goldstein.
All the time.
I say
I
you
have
should be
access to
Goldstein.
the listserv.
I think Goldstein's the best.
What do you think?
I
To be fair, his research is cool.
I don't. Honestly, if you got Goldstein, I wouldn't.
I wouldn't be mad. He's my letter of recommender for grad school.
Really?
One of them, yeah. I asked him because I figured he'd be good enough.
For like from ULM.
Yeah, he probably knows you some of the best compared to all the other Kenny professors.
When's your grad school application?
Pick up a new assignment, okay? Whoa, a new assignment.
Taxes due January 15th. But like, I'm not going to tech.
I just gotta figure out my
I'm
grad
just
school
gonna accept
situation.
a 6-figure job before I go to grad school.
I'm gonna try to cook up that career fair next week.
Same. Yeah, that's the whole.
Although sometimes, is it bad for like the first 3 companies, or like I choose like a couple, or it's just like I completely pretend to be somebody else?
What do you like? You're not going to grad school?
Yeah, no, I just print a fake resume.
Oh, wait, is that what the other resumes were?
Dude,
It just took one time.
I'm gonna
I'm a-
totally play them and say I'm not going to grad school
Oh yeah, no, I'm not telling them I'm going to grad school.
and see what they do.
If it comes up in the interview, because sometimes
Yeah.
for research and development, for a lot of artists, they might be interested. They're like, hey, work for us for like 4 years and then you can go to grad school. We'll like pay you extra. We'll still be on payroll.
I'd be down with that.
I would.
Sorry, dude.
I just want a job now.
Money.
Yeah.
Money good.
Just like spend it all. Yeah. Yeah.
Losing.
Yeah.
Losing.
To be fair, I haven't been spending money on alcohol. He said it's on purpose.
There you go.
I gotta do out.
This is way too big.
Wait, where did you get that?
This is our lecture note. No. So you pick this up. I think he gives this to me. Because you use your notes, I think. But
Nice. Let's see. That's sad.
I don't even care, bro. I don't even care.
That's fair.
I would say hi, but
Hello, come forward to pick up your new assignment.
Well, I just meant like, are we doing this like, so is this at homework? Because I can't tell.
whatever it is, you bring it out. Appreciate that.
Do I like write this? Is this like a pop quiz? Because I really don't want to do a pop quiz.
That would be funny.
Well, at least I'm not the smartest.
The what?
One of the smartest ones. Because none of them know how to do it.
Dude, we're actually good.
What?
Because we're the only two that know how to do it. We're not good.
Oh, no, they're fucking.
That's what I'm saying.
Oh, yeah, sorry. No, because like realistically, for Keen, probably not.
Yeah, no fair. Bro, check this
Come
out.
forward to pick up your new assignment.
This is what I did between the third and this class. It's literally just reactors, the operations.
Yeah, no, I don't have to know.
I was like,
I'll figure that out another day. I'm just being continued.
Okay, let's get started.
Well, right now we're just reviewing.
Check your email for the solution. You ready? I looked through some of the solution emailed to me. The problem is you do not give sufficient detail for the second best, third best, and worst sequences. So you look at here, this is Ki, component A relative to E. That's a reference component, Ki or K reference. To apply heuristic for separation, you need a relative volatility of two neighboring components. You need Ki over Kj, Ka over Kb. So, alpha Ij is Ki over K reference. Right here, Kj over K reference, right? Ratio of the two. And you find out the last split should be done last, most difficult split. And you check to the relative mole fraction, molar flow rate. There is no component dominating the feed. So, which split should be done first? This is why you use CF for auto split. How do you get 4.63 between A and B? 0.05 over 0.95 times relative volatility minus 1 times 100. So you do the same way. You find out this initial split between C and D. What is the advantage of this? You notice this is 45, this is 55. Close to 50-50 split. And relative volatility, 2.48. that is largest among all split. You multiply them together, CES. This is what in the first split. Now, split between D and E, difficult and last. That's done. The next question is, what do you split between AB or BC? You set up a comparison. Flow rate ratio, relative volatility -1 times 100, product of the two, CES. This heuristic, CES, says this in terms of relative volatility 1.88, and this in terms of 1.287. If you do performing easy separation first, you might follow this one, split A from BC. That is done in all the chemical engineering textbook, unfortunately. Why? People chose the wrong heuristics, performing easy separation first, while they ignore. This is very poor flow rate ratio, 1/10. And this one better, 20/25. And the product says, CES, balance two consideration. Perform easy separation first, or favor 50-50 split. So, AB from C is the better one. That is this. So, this, number one, exactly follow our heuristic. How about number two? And you notice AB from C, A from BC. That comes from this comparison, right? And this A from BC, right here. This heuristic, no good. That split is no good. So violate CES. That's why it's second best. And the first one is good. The second one is not good. That's why this end up number 2. Now, the third sequence, you notice is split. A from BC, D, E first. That's CES, the smallest. That is not good. Here, BCDE, D is last. Difficult separation. Right? So, question is, do you split from here or here? Okay? So this, you look at this split. A, B, C, D, E, A, B, C, D, E. Now, for this part, what do we do? Do you separate B from CDE or BC from DE? B from CDE, BC from DE. You go through CES analysis. This is the best. Why? Close to 50-50 split. Okay? And large relative volatility too. R is 2.48. So, perform easy separation first, favor 50-50 split. You prefer this, BCDE. Okay? And this one is good. This is good, but this is real bad. That is the difference. Last one. Perform difficult separation first. That's crazy. Right? DE is the most difficult separation. How about A, B, C, D? Do a split here, here, or here? Some of you emailed me a solution. I said you did not give sufficient detail for the last 3 sequences. What do I refer to? You did not compare the split. Look at page 3. A from BCD, AB, ABCD. You did not do that. Okay? So, you solve your homework problem in the future, be quantitative. And what happened is, this split, they choose the worst one. Split A from BCD. And after that, what do you do? With BCD. B from CD, BC from D. And this is worst. So, worst, worst, worst. Of course, that's number 4. Any question? Yeah. I cannot hear you. Say it louder.
In analyzing the sequences, you prefer to have tables for all the calculations for the small.
You don't need all the table, just write it the way I did. Yeah.
Is it a very common practice to giving relative volatilities and calculating relative volatilities?
No, depending on the relative volatility, what the heavy component, reference component. Okay, in this case, you have 5 components, right? The given relative volatility is with respect to the carbon 5. Okay? For split, it's 2 neighboring components. No more, which is 5, no more. Next slide is easy. I do not need to explain, all right? Once you find normal boiling point, this is one split. So, you find out CES for the first split, right there, between AB. Okay, AB. Because CD is one product, is given. Do not break a multi-component product. Okay, you got a new page today. Who does not have it? this simple assignment, due Friday, solution should be less than half a page. If you think it through. Look at all this component. First thing is separation system. You want product, right? This is the product. What happens is you want to insert and propane in another product. That's not good because there is a middle component between the two. And then you want all the other trade in the third product. That's the first thing you need to think. What are your products? You cannot split it this way because minus 48 boiling point. You cannot split it directly. So, how do you change the relative volatility of normal boiling point sequence? The problems give you relative volatility of carbon-3 to carbon-3 minus, carbon-3 minus carbon-3. In the presence of solvent, you can make carbon-3 more volatile than carbon-3 minus. In other words, you add a solvent, you might reverse the sequence. You go home and think, which is a good solvent? Develop a final separation sequence. My solution would be half a page. Yours and yours 1 page. It's a thinking problem. Between now, Friday and noon, think about this problem. When something come up, you got the tricks. Dividing it up, 5 minutes. Okay? This one, I'm a hard solution. I want to read it myself for every one of them. I want to see who is seriously thinking. Okay? Any question? Yeah?
So what's the actual final solution that you want? Do you want us to figure out what solvent is in it, or?
For this problem, you just develop a whole solution to PE. 1, 2, 3. You give me the 1, 2, 3 product, right? Product. No, I want you to give me the separation system. Okay, no more? Oh, we still have time. Let's get on to the new topic, okay? Topic 2. Now, we do need to cover as much material as we can while we have classes. This semester is really tough. I cannot have class on Wednesday of your engineering expo. I lost 1 hour. Last 2 days, I saw another email. I lost the whole Friday afternoon. Football game. University canceled class. Bad. Those are 4 hours already. So while we have class, I hope you understand why we need to learn new material. Okay? All right, look at this one. What happened? No? What happened? Reversed it. I did not do anything. Somebody come forward. I don't know what happened. No way. What the touch? Someone come forward and help. Reversed it. What happened? Come on. I don't know. What did I do? Is this really touch?
Sorry.
No. Oh, no. That's better. Make it smaller. Here. Nope. How to make smaller? Yes, smaller. I can see more. It's not the same. Nothing.
You can try lifting the camera up. Like move the camera up, see if you can.
Okay, okay. All right, good man. All right. I'm going to explain about 10 minutes or 5 minutes, and then I'll ask you a series of questions. First, temperature composition diagram. Pure benzene, 0 mole fraction. Pure benzene is right here. Mole fraction benzene is 0. Mole fraction benzene is 1. XA. Okay? So, this is temperature versus composition of A, benzene, in the liquid phase. Here, temperature versus composition of benzene in the vapor phase. Why do we go through this? You need to understand the 5-phase condition. Suppose I start this temperature, given the composition here, that means mole fraction of benzene is about 0.6. Temperature 116. Now, if you lower the temperature, you touch this point. And this initial temperature is called superheated vapor, while the temperature is above the saturated temperature for vapor. This is vapor, saturated vapor. Why is a dew point? Dew point temperature is that if you lower temperature by 0.1 degree, you see the first drop of liquid. Vapor becomes liquid plus vapor. So, this is the dew point, this liquid plus vapor mixture. You lower the temperature more, this is a special point. We call it bubble point. What is the bubble point? You have a liquid mixture, saturated liquid. If you raise the temperature by 0.1 degree, you see the first bubble of vapor becoming liquid plus vapor. And this is called bubble point temperature. To summarize, saturated vapor is a dew point temperature. Saturated liquid is a bubble point temperature. Now you lower the temperature more. This liquid temperature is lower than bubble point. We call this subcooled liquid. So, subcooled liquid, saturated liquid, liquid plus vapor, saturated vapor, superheated vapor. You understand the 5 different conditions. And what is dew point? What's bubble point? Okay? Now, here comes the challenge. How do you choose operating temperature, pressure, distillation column? You look at the diagram, we have column, this is the condenser, this is the reflux drum, condenser, reflux drum. This is the product cooler. At the bottom, you see the reboiler, product cooler. So, think about column, condenser, reflux drum, reboiler. You may not need this cooler. My first question is, which piece of equipment, column itself, condenser, reflux drum, reboiler, determine operating temperature pressure of the column? What is answer to the first question? Among the 4 pieces of equipment, which one determines operating temperature pressure of the distillation column? Yeah. Wrong. By process of elimination, by the 4th person got answer. Huh? Wrong. Who said that? What's your name? Good man. Okay, not done yet. I want to see how many questions you could answer. Question 2. What is typical operating temperature of reflux drum? 200 degree F 100-degree air, 60-degree air. What's the number? Magic number. You do your lab experiment. There's a basic question on distillation column. Yes?
I think 250.
250, too high. 68, too low. 100, slightly low. You don't know the answer? Yeah?
110,
100 what?
110.
110? That's close, but not exact. Okay, now, reflection pressure. Let's look at here. TR, 120-degree F. What is PR? I do not know, but if I know the distillate composition, XID, distillate mole fraction, and coming out of reflection, composition is given, temperature is given, what is this reflection pressure? Okay? First thing you need to think about, coming out the reflection, what is the phase condition? What's the temperature? So, look at the next question. If you know the distillate composition, XID, you know TR, 120-degree F, PR, reflection pressure. Now, come back to this plot. Whenever you want to define a dew point, a bubble point, you need composition, you need temperature. Okay? In this case, pressure is fixed. So, temperature, pressure, composition determine dew point or bubble point. Okay? So, come back here. Question number 3. First thing is, reflux drum coming out, is that a saturated liquid or saturated vapor? Liquid or vapor? Liquid. What's the temperature of saturated liquid? Pressure of saturated liquid? What do you call it? Yeah? No answer?
Repeat the question.
I know the composition. I know the temperature. I know this is a saturated liquid. What is the name of this pressure?
Saturation pressure.
No, not correct name. What's the name of this pressure? Yeah. Vapor pressure, no. Bubble point is saturated liquid, right? It's called bubble point pressure, understand? The cold saturated liquid is bubble point. If you know temperature, you find the pressure, it's called bubble point pressure. Now, PR, E, reference drum pressure less than 250 psia, between 215, 365, larger than 365, what type of condenser do you use? Remember, a total condenser totally condensed vapor into liquid. Partial condenser, partially condensed vapor, you have a vapor product, liquid product. If you need to use refrigerant, you would have refrigerated condenser. So, what is the answer? Remember in the first lecture, I told you about operating condition. Temperature, low, high, pressure, low, high, right? In the first lecture, temperature low, refrigeration, heating. Pressure low, vacuum, high pressure, compression. Right? At that time, low. Is that a good combination? Expensive or inexpensive? You need to use liquid helium, you need to use vacuum pump. Is this here yes or no?
No.
You don't remember I say hell no. Alright? Do you want high temperature, high pressure?
No.
Hell no, right? So, if pressure is high, refrigeration, that is okay. This is okay. That is what we learned from the first topic. No, you apply to here. High pressure, you better use refrigerated condenser, right? Here. How about those two? Total, partial, which is which? Which is which? First one, low pressure. Do you use the total condenser or partial condenser?
Total.
No answer? Yeah? Okay. More. What is typical gas phase pressure drop across the top condenser? How many psi? Give me a good number. Yes.
30,
Too much.
20.
Still high. What is the typical pressure drop across a heat exchanger?
Near zero.
What's the answer? Oh, you're bad.
5.
You're bad. Okay, now, let's see. If I know reflux zone pressure 200 psi, right? Then this is the total condenser, right? Right? There's delta T 5 psi. So 200 plus 5, 205 psia. Right? Top pressure top. Delta P 5 psia. Okay? Now, if I have 30 stages in the column, what is the delta T of the column? Let me ask you one question first. I know this pressure. How about composition? Y-I vapor. Top vapor. If I have a total condenser, that is equal to XID. You totally condense the top vapor into distillate, right? Composition is the same. Right? Composition is the same. So, you know the saturated vapor, you know the pressure, you know the composition. Question number 6. Oh, I gotta hurry up. You know pressure, that's 205 psia. Top state condition, YIV equal XID. What is the top vapor temperature called? It's a saturated vapor. What is this temperature? Yes? What? Yes, good. Dew point temperature. Okay, hurry up. You got 2 more questions in 5 minutes. I'm asking you a question. What is the delta P per stage? How many PSI in distillation column? What's the heuristic? 10, 1, 0.1. Come on!
5.
No good. Too high.
0.5.
Are you? Oh, hey, I was close. Hey, I was close. Hey, margin of error?
That's very
Okay. Let's look at the diagram again.
I was so sorry.
Last question. So, 2-5, 30 stage, 3 psia. Here, pressure at bottom is 208 psia. And this liquid is saturated liquid. This bottom, look at last question. So, bottom stage pressure, we find out 208 psia. We got the bottom composition, XIB, is a saturated liquid. What is this temperature called? Last question. Come on.
bubble point pressure.
So, how many answers did you get right for the 8th question? How many did you get right? 4, 3? Who said 8? You did not get it right. Be humble. Learn something good on Friday, okay? That's it.